Okay, class, this is part B of part 2. So once again, I do have limitations on the videos. I'm trying to keep them under 10 minutes so they could upload faster on YouTube. So in this particular example, it's a little bit different than our previous ones. Notice that now we have coefficients in front of those right there. So practically it's the same thing. What we're going to first of all do is distribute that 3x. And once again, take your time on this. Just pretend that this -2 is not on there. So just like before, 3x times -5, that will give you -15 x squared. Remember, you do not multiply technically you do not multiply the variables. You actually end up adding the exponents. It's only the coefficient part that you multiply. Same thing here. 3x times -6. 3 times -6 is -18x. So that takes care of that one. And now we're going to go ahead and take a look at -2. So we're going to distribute the -2 times -5x. So -2 times -5, that becomes positive. So it'll be positive 10x. Since the 2 doesn't have an x attached to it. And finally, we have -2 times -6. -2 times -6 is positive 12. So once again, we completely distributed both the 3x, which gave us these two, and then we go ahead and distributed the -2, which gave us these two right there. If you take a look, we could go ahead and collect these two right there. So this will end up giving you -15x squared. And we collect these two, -18 plus 10x. Remember, you subtract, keep the sign of the large one. So this will be -8x. So that takes care of those two. And you go ahead and bring down the positive 12. So that would be your answer for letter D. -15x squared minus 8x plus 12. All right. So that's a kind of different problem right here. Now we're going to take a look at our next one right here, letter F. So letter F looks a little bit weird because we don't have it as two separate polynomials. Here we have essentially 6x minus 3 squared. Well, think about it. This is the same thing as saying like 5 squared. 5 squared would have been 5 times 5. So when they give you a polynomial like this, you're multiplying that polynomial times itself twice, since we're dealing with a square. So you're going to rewrite this. So you're going to rewrite this as 6x minus 3 times 6x minus 3. So however many times that number is, that's what you're going to do. Just the same thing as what we do before with numbers. So we're going to go ahead and take a look now. We're going to go ahead and distribute the 6x. Since that's our first number, 6x times 6x, that's 36x squared. Remember, we're distributing the 6x. We're going to do the same thing for the next one. 6x times -3. 6 times -3, that's -18x. Since there's no x with it, scratch it off. That's very important. And you repeat the same process, but now you're going to distribute the -3. So the -3 times 6x, -3 times 6 is -18. And we bring the x. Do the same thing for the next one. -3 times -3, that gives you positive 9. So we end up with this particular problem right there. So we have 36x squared minus 18x minus 18x plus 9. Once again, we could go ahead and collect these two. So we have 36x squared and you collect these two, so this will be negative 36x, because negative 18x minus 18x will give you that. So once again, if you collect these two, that gives you that. And we bring down the positive 9. And that would be your answer right there. Once again, you're going to have to repeat this video a couple of times just so you could get the hang of it. But essentially, it's basically the same thing that we did before. All right, so how about fractions? Well, just like everything else, fractions are sometimes a little bit bothersome because we have to do a little bit more work to them, but it's nothing that we cannot do. So we're going to multiply, we're going to distribute the 1/2 x first. So keep that in mind, that we're going to multiply 1/2 x times 1/3 x. Once again, there's nothing that we could cancel out in the diagonals. So 1 times 1 is 1, and 2 times 3 is 6. Once again, do not look at this negative 1/3. Just look at the 1/2 x times 1/3 x. And then x times x will give you x squared. You repeat it with the next one. The 1/2 x times the 1/4. Once again, there's nothing that we could cancel out diagonally. So 1 times 1 is 1. And 2 times 4 is 8. And since we have x, but we don't have an x here, we just leave it alone. So that takes care of the 1/2 x. So we repeat the same process all over again. Here we're going to go ahead and distribute the negative 1/3. So negative 1/3 times positive 1/3 x. So this will give you negative 1 times 1, that'll be 1. 3 times 3, that'll give you 9. And we bring down the x. And now we distribute the negative 1/3 times the 1/4. Negative times a positive, once again, will be negative. 1 times 1 will be 1. And 3 times 4 will be 12. All right. So this is what we have here. But remember, just like before, we're going to have to collect these two. So we're going to have to do a little bit more work. Some scratch paper here. So I'm going to do on a separate sheet right there. And I'm just going to take the coefficients, the 1/8 and the 1/9. I'm not going to worry about the x's because we're going to have those. So once again, we have 1/8 minus 1/9. Remember, when we add or subtract fractions, we need a common denominator. Just to save us some time here, the LCD here will be 72. So both the 8 and the 9 could go into 72. And essentially just write it into equivalent fractions. To get 8 into a 72, we multiply it by 9. So 9 times 1, that'll be 9 over 72. Same thing with this one. To get the 9 to look like a 72, we multiply by 8. And once again, it's your choice if you want to write them down to visualize it. You don't have to if you already know how to do this. So 1 times 8 will be 8. So once again, since the denominators are the same now, just simply subtract. 9 minus 8, that'll be 1, and it's positive. So 1 over 72, so this will be 1/6x squared. Remember, that does not get touched right there. When we collected these two, this became 1 over 72x. And once again, the way we figured it out is just simply subtracting the fractions and finding the common denominator. This is what we did right there. And we go ahead and bring down the 1/12. So that'll be our answer right there. Once again, nothing difficult. It's just a little bit more work than we're used to. All right, so this concludes part 2B of section 4.4.